All right, here we go for part 3. I kind of blew the end of part 2 there, folks, because I forgot that there's this little activity that we do. This if it was a regular classroom, this page 204, we would do sort of together really quick as a class. But we're not sort of together as a class, so I'm going to do these examples from the textbook right now. And there's the in-class activity that I threatened and warned and promised you that I'd take 20 minutes or so out of class to do. That might not take that long, but we're going to do this as an in-class activity, review activity. And here's the together part. So the together part here is number 1 and 4 from this page. So state the zeros of the following functions. Now notice this is a function, not an equation, but the zeros are what we would think of as the x-intercepts. So this is really, really easy, right? We can do this really quickly together in our head. That this gives me an x-intercept, a 0 of 2, minus 2, 1, and 0. So here, just listing them off. And this is nothing new. But the idea here is the intercepts of this function, which we're used to finding, it's already in factored form, so that's good for us, that are also the solutions to this related equation. There's this connection between equations and functions that's quite natural for us, right? So this is solving the equation, is finding the zeros of the function. And notice down here, for instance, minus 6 is a triple root or a slide root. Here, if I have trouble seeing what this factor gives us as a solution, that remember I just set that equal to 0, and then I can find that quickly if I can't see it, that it's 5/2 in my head. Notice they get a little tricksy near the end here that you actually have to factor a couple of quadratics, but that should be no problem. That factors into x minus 3 and x plus 3, so I see the solutions are 0, 3, minus 3. The zeros of the equation, x-intercepts of the function. What was the other one I wanted to do? Number 4. What's number 4? Explain how you can solve that using 2 different strategies. I'm actually going to give you 3 strategies. One of them, the first one, would be how we did it in class, would be to move all this stuff over there and then start using the factor theorem. So one is get one side equal to 0, then use the factor theorem. Probably what they're talking about, 2 different strategies, are using the TI-83. So using the TI-83, what we could do is just solve, graph the left side is y1. I'm going to do that different. Graph y1 equals the left side, this big long expression. Y equals this. And I could graph y2 is the right side. And then I'm going to look for intercepts. Number 3, which we actually didn't do in class, would be a kind of a combo of these 2 things, is that I could move all this over to one side, get one side equal to 0. Then I could graph, need a little more room here, then I could graph y1 equals whatever that is, and then look for, if I put all this over to one side and this is 0, then I could graph this side and see when it crosses the x-intercept. So, x-axis rather. Look for x-intercepts. You see the difference? Here, I'm graphing the left side and the right side and looking for where they cross. And on the third one, it's a TI-83 method, but I move everything to one side and look for the x-intercepts. Essentially, my y2 is equal to 0, but that's how we get the x-intercepts anyway. And I could use the graph to solve the related equation. All right, so that should have been on the last video, and now we're doing the in-class activity, and the homework's actually, I think this is in the way, homework's actually right there, but it's also on your sheet, so it's all good. That's it for part 3.